Welcome all. So, today we will be dealing with structural elements subject to impact. Okay. So, we will start the lecture. So, today the lecture will be divided into three parts. The parts 1 will cover the general concepts related to energy absorptions. Okay. So, we will be looking into the basic principles covering the energy absorptions. Okay. And this will be in the case of structural systems subject to impact. Okay. So, we will be looking into the scenario where the structure is subjected to impact loading, and then we will try to design the energy absorption devices. Okay. So, it will be a continuation of the last lecture also, but we will be looking into the different specific case scenarios with the basic principles, and we will be elaborating more on the different aspects of the design. Okay. So, you can assume that the previous lecture was walkthrough to the entire system, and this one will be a detailed looked out into the design of energy absorption systems. Okay. So, after we have covered the general concepts, we will deep dive into the case study of the design of an energy absorption system. Okay. So, when we say case study, we will be looking into the real life problems. Okay. We will be looking into real life problems where we will have different scenarios, and in the different scenarios we will be look into the how the energy absorption system for a structural element has been devised, okay, for an impact case scenario. Okay. So, after that we will be also looking into the different examples, we will be looking into the different trends that are being used in the energy absorbing material, the new materials, their systems, and so on and so forth. Okay. So, after having this lecture, okay, our aim is that we are very much comfortable in designing the energy absorption system, and whatever we have learned, the basic principles, the energy calculations, okay, we can implement into the different case study. Okay. So, we will be starting the lecture. So, part 1. So, in the part 1, what is the importance of impact energy absorption? Okay. The main criteria is to dissipate the kinetic energy. Okay. When a vehicle, okay, or any impactor is moving with a mass and a velocity, okay, it has a large amount of kinetic energy. So, in the classical way, the kinetic energy is given by this expression. Okay. So, it is proportional to the mass directly, and velocity it is squared. Okay. So, our aim for designing the energy absorption system, okay, is to minimize the damage and system failure. Okay. So, what energy absorption system has to do? It has to dissipate the kinetic energy, and in the due process of dissipating the kinetic energy, what it needs to do is it needs to minimize the damage and the system failure. Okay. So, as we have seen, our impact loading is loading with a very high amount of magnitude of force, okay, and that is applied in a very short time duration. Okay. So, what happens? Okay, due to this type of loading, this signature of the loading, there is a rapid change in the momentum. Okay. Our aim is to minimize the system failure and the damage, and also to reduce the fatalities and injuries. As the last time we see, our goal was to minimization of the injury, plus the first goal was minimizing the injury, second goal was to reduce the system damage, and third goal was to reduce the damage to the peripheral systems. Okay. So, this is the principle in which the design of the energy absorption system occurs. Okay. So, the paramount becomes the reducing the fatalities and injuries to the occupants, second becomes the minimizing the system failure, and third becomes the minimizing the damage to the peripheral systems. Okay. And this is achieved by dissipating the kinetic energy and absorbing the total energy of the system, okay, during an impact event. Okay. Moving ahead. So, now we will be looking into the application of the energy absorption systems. Okay. So, as we have seen earlier, the application of the energy absorption systems cover packaging fragile items, okay, whatever courier we receive in the homes, okay, be it electronics, be it other fragile items, okay, or somewhere glass items, okay. So, they are always protected by a protective packaging cover, okay, and normally they have some sort of cushioning material. Okay. So, if this is my package and if this is my electronic or any fragile item, okay, there will be always some sort of cushioning. Okay. It can be made of foam, it can be made of PU materials and any other materials. Okay. It can also have a geometry of honeycomb geometry, okay, or any other geometry, okay, that reduces the total impact energy. Okay. Other area of the energy absorption system is transportation. Okay. This one we looked, where we looked into the design of the different systems in a car. Okay. We were looking into a system where a human head comes into contact with the back seat of the car, and the design and the detailed design of this back seat of the car we looked into. Okay. We looked into the head injury criteria, okay, and we looked into the acceleration due to gravity. Okay. So, as per the medical norms, the head injury criteria has to be less than a certain number, and the amount of G, the amount of the acceleration, okay, has to be less than a certain criteria. Then only this system is said to be an efficient system. Okay. And we looked into the back seat of the car, but there are other systems also which deal into this thing. Okay. The other applications are aircraft fuselage, okay, the part, okay, where the fuel and the other peripheral devices are stored in the aircraft. Okay. There also the energy absorption systems are applied. Okay. The bumpers of a train. Okay. In the case of high speed rails, okay, if you look into the case of high speed rails, the nose will be this type of protruding part, and okay, and if we cut open this section, okay, there will be a spring mass system out here, okay, or an equivalent spring mass system out here, where the total energy, okay, by this system is being absorbed. Okay. This is also called the sacrificial layer, okay, where the failure occurs something like this. Okay. It will be crumpled like this, but it will absorb the total energy. Okay. So, these are the train bumpers. Okay. So, they can be in the nose, also sometimes the bumpers are also in this shape. Okay. In the conventional railways and all, bumpers are also made in this shape, okay, where if the impact occurs, this bumper is able to absorb the energy. Okay. In industry, the applications can be in the field of mining field, okay, where cage arresters are made. Okay. If a cage is lowered, okay, inside the mining shaft, okay, there are cage arresters. Okay. This are also seen in the normal lifts also, where if you look into beneath the lift in the ground floor, there also we will see the impact energy absorption systems. Okay. So, basement of the lift, in the normal applications we will see energy absorption systems. In case of mining shafts, this will be made in the side faces also, as well as in the bottom also. Okay. Forklift crash protection, if you are using a forklift, okay, say let us say we are using a forklift, okay, to deliver the materials and all, okay, or from transporting from one point to another. Okay. So, in this case also the energy absorption systems are in place. Okay. So, these are some of the common examples of the use of the energy absorption systems. Okay. Continuing ahead, personal safety devices, helmets are well known. Okay. So, in this helmet, okay, if we cut open the cross section of the helmet, we will see this different type of cushioning materials are there. Okay. So, this type of cushioning materials are made of two different layers. Okay. One will be a hard layer, okay, a ceramic type of layer, okay, and the other layer will be made of a soft material, okay, maybe foam, PU foam or other materials. Okay. So, idea is to dissipate, okay, or distribute the energy across this hard armor, and then the hard armor will again transfer the impact energy, okay, and it will be absorbed using this soft armor. Okay. So, it is a combination of a hard armor plus a soft armor. Okay. So, this is how normally the helmet works. Okay. So, one more criteria of helmet is that whenever an impact occurs, okay, so what will happen in the impact? Okay. It will normally happens at a localized area. Okay. So, during a localized area, if this is the plan and if we look into the section, okay, this is how the section, if it is only a metallic plate, okay, this is how the section will try to deform. Okay. And our head is here, okay, the human head is here. Okay. So, it will cause a direct injury to the head. Okay. So, this type of injury, okay, though here we can see that the impactor has not breached the helmet, okay, but due to this indentation, okay, there is a serious injury to the head. Okay. So, in the case of design of helmet, this thing has to be prevented. Okay. So, that is why there is always a cushion of the hard armor and the soft armor, where hard armor takes the total energy and it distributes the energy to the large surface area, and after that, that energy is being absorbed by the soft armor, so that this type of indentations does not occur and the head is protected. Okay. Then in the normal infrastructure, like a crash barrier, okay. So, design of the crash barrier we have seen. Okay. So, a crash barrier is along the roads, okay. If and its idea is that if a vehicle hits, okay, it should deform in a large plastic sense, okay, over a large amount of distance, so that the total energy is being absorbed by this impact and the occupant as well as the car is saved from the impact. Okay. Many times the crash barriers are also, okay, or they are called median barriers, okay, they are also in the between the two roads, okay, between the ongoing and upcoming roads. Okay. There also its purpose is to save the vehicles, the occupant as well as the vehicles from any impact. Okay. Parapets. So, in case of roads, okay, in the high altitude region, okay, sometimes a large parapet will be designed, okay, to protect the vehicles from the falling off the cliff, okay, or absorbing the impact energy. Okay. Similarly, bridge fenders will be there. Okay. So, these are the different types of energy absorption systems, okay, that are employed in the transportation field. Rockfall protection, we have looked into detail about the rockfall protection, okay. The design of the rockfall protection. So, it will have a netting type of system, okay, and this netting type of system will be anchored in the hills, okay, and it will be held down by this anchor, and if some rock falls occurs here, okay, so this will protect the rock from hindering the vehicle movement. Okay. So, we have seen the design of a rockfall system where it can stop a vehicle moving at a velocity of around 60 km per hour, okay, and the vehicle is around a 2-ton vehicle, okay, our normal car, okay, this mimics the normal car. Okay. So, different types of application of energy absorption systems we have seen. Okay. So, moving ahead. So, now we will look into detail about the different devices, okay, personal safety devices. Personal safety devices like helmets and body armors are used. Okay. So, various auxiliary protective devices like bicycle or motorcycle helmets. Okay. So, these are the conventional things. Okay. A bicycle or a motorbike helmet, okay, which sometimes looks like this. Construction hard hats are being used, okay, which sometimes look like this. Bulletproof jackets, okay, this is the bulletproof jackets, and all are required to possess high energy absorption capacities. Okay. We can add your armor helmets also, okay, which can, these are the armor helmets. Okay. So, if this is the jacket, okay, then there should be an helmet here also, okay, which should protect against the live firing. Okay. So, as the jacket protects the body from the bullets, okay, the helmet also protects the head from the impact of the bullet. Okay. So, conventionally these jackets are made from a combination of your hard plates, okay. There will be hard outer plate. Okay. So, if you look into the cross section, okay, and if this is the impactor, there will be a hard plate. After that, there will be some sort of cushioning materials, okay. There will be some sort of cushioning materials, and then there will be one inner layer. Okay. So, the theory is that if an impact occurs, okay, let us say a bullet hits this thing, okay, a bullet, if it is left with only a metallic plate, what will happen? This bullet will try to penetrate the metallic plate. Okay. So, two things can happen, either this will cause a large indentation, okay, it will cause a large indentation, the impactor, which will again hit the body parts and cause severe injuries. Even if it is not able to penetrate, it will cause this type of injury. Okay. Or if it it is able to penetrate, okay, then the effect of the bullet will be transferred to the human body, which can be catastrophic. Okay. So, this same thing applies in the body jacket also, and this same thing applies for the helmet also. Okay. So, what is being done is that a hard plating is applied. Okay. So, what a hard plating does? A hard plating will try to distribute this impact energy over a large surface area. Okay. So, if it is dissipated over a large surface area, the amount of energy per unit area what it has to mitigate becomes less. Okay. So, the total effect of what the body sees becomes less. Okay. After that comes the soft part, okay, the soft armor parts. So, what will happen is that the soft armor, it will have a large plateau, as we have seen earlier. Okay. Force versus deformation, if you see of a soft armor, it will have a large plateau. Okay. So, it will have a large area, okay, inside the force deformation curve. Okay. And this large area denotes the energy absorption capacity. Okay. So, using this configuration, okay, and using this material property, okay, this soft armor is able to absorb the effect of the plate, okay, effect of the impact into the body. And after that, there will be one inner layer which will try to give the reaction forces to this body. Okay. So, the use of this layer is that it will try to give the reaction to this body, reaction to the soft armor, such that less amount of energy is transferred to the human body. Okay. So, this will protect the human body from any sort of injuries. Okay. So, this type of theory is applied in the conventional design of the armor of both jackets as well as helmets. Okay. So, there is one more application here also. Okay. So, here we talked about a hard and a combination of a hard and a soft armor. Okay. So, there is one more new application, okay, where we deal with a liquid armor. Okay. So, in liquid armor what happens? Okay. In liquid armor there is something called a shear thickening fluid. Okay. So, if we take let us say we are taking cornstarch, okay, a commonly available material. Okay. So, if we make a paste of a cornstarch, okay, this is paste of cornstarch, okay, this is cornstarch paste, okay, and if we try to put a needle very slowly, okay, what will happen is that the needle will go through this cornstarch. Okay. If we take a knife, okay, and if we try to protrude it, okay, with a very high velocity, okay, if we try to jab it, we try to jab the knife into this cornstarch, what we will feel is that there is a significant amount of resistance from this cornstarch. Okay. The knife will not easily go through. Okay. So, this behavior, okay, is known as the shear thickening fluid. Okay. What happens here is that during relatively less amount of movement, okay, the fluid remains stable, okay, and it allows the impactor to pass through. Okay. But if it is coming with a very high velocity, okay, what happens is that the nearby fluid also engages, okay, and it forms a layer out here. Okay. So, this type of zone is created, okay, and this type of zone, okay, formed by the molecules of this material tries to resist the impact. Okay. So, higher the velocity, higher this configuration will be formed, okay, higher the concentration of these molecules will be there. Okay. So, this is known as the shear thickening fluid property. Okay. So, using this property, okay, now the armors are being tried to design. Okay. So, in the design of this liquid armor, what is happening is that first of all some sort of plating is required, okay, to distribute the energy over a layer. Okay. Once this is done, in the second layer, this shear thickening fluids, okay, this shear thickening fluids are arranged in different small components. Okay. So, once the impact comes, the energy is distributed over a significantly large area, and then this energy is transformed, okay, over this boxes filled with shear thickening fluids. Okay. So, higher the impact energy, the better the behavior of this shear thickening fluids will be. Okay. So, this type of energy now it is being transferred to this layers, okay, and these layers are very efficient in absorbing the total amount of energy, okay, and then there will be a third layer, okay, which will provide as a reaction, okay. So, if we use this liquid armor concept, okay, and if we can make the first layer, okay, the dissipating layer using a fabric type of material, okay, where it is not allowing the impactor to tear the fabric material, okay, but it is allowing it to dissipate the energy over even a smaller area, then the liquid armor, the shear thickening fluid can be engaged and it can be used to dissipate the energy, okay. So, using this concept, okay, armor can be designed, okay, so that it represents a normal clothing, okay, it comes in the form of any normal clothing. What is the difference between the liquid armor and the conventional armor? Okay. In the conventional armor, it is very tough to mold this thing into a body shape, okay, and there will be some stitches, okay, whenever we are connecting the hard plates, okay. So, here the stitching will be there. So, the stitching, this portion proves to be the Achilles heel of this armor, okay. So, in the case of the liquid armor, since this is made up of a liquid gel type of thing, okay, it can be molded into any shape and it can be easily given the shape of the body, okay. And the stitching, in the stitching part also we can, in the back layer we can apply the liquid armors, okay, the shear thickening fluids, so that this Achilles heel portion is minimized, okay. So, nowadays this liquid armors are being developed throughout the world, okay, and hopefully it will be soon in the usage, okay. So, this is the important innovation which has come across in the design of the armor. From the conventional hard and the soft armor, we are moving into the design of the liquid armor as well, okay. So, moving ahead, now we come to cars, okay. As we have seen, the cars have different components, okay. So, the different components as given by the automotive industries are called as B pillar, the roof rails, A pillar, upper rails, lower rails, okay. So, here the concept of the design of the car is being signified by this diagram, okay. So, the most vehicle body frames are thin walled steel columns, okay. What does it mean? Okay. The frame is made up of a it's a thin wall type of system, okay. So, it acts on the principle of a column, okay, or struts, okay. So, the upper and lower rails in the front part of the vehicle body are the main crash energy absorbing members. If you look into this zone, okay. So, this entire zone is being designed to absorb the energy, okay. So, if you look a post impact scenario, this entire front part, okay, will be crushed, okay. So, it is designed in a way so that the entire front part gets crushed and it protects the body, okay, this body, okay, where the people sit, okay. So, this should be shielded off from this impact energy, okay. So, the front part is called the crumple zone, where it will be crumpled, okay, and it will try to absorb the maximum energy, okay, thereby protecting the occupants, okay. So, upper and the lower rails in the frontal part of the vehicle body are the main crash absorbing systems, okay. So, this upper rails and the lower rails, okay. The bumpers of a vehicle may play a role for a minor frontal or rear impact, okay. This portion, okay, the bumper, this also might play a role, okay. So, what will happen to the bumper? The bumper will try to do like this, okay, thereby absorbing the energy, okay. So, this thing we can find the equivalence to our crash barriers, okay. In the crash barrier also, this is made up of energy absorbing material having a very large plateau, okay. It has a very large plateau and the deformation here is also more, okay. So, the same way our bumper also behaves, okay. So, this way the car is designed to absorb the energy, okay. So, the back zone, okay, if you look into the back zone, the same principle is also applied to the back zone for an impact occurring from the rear end, okay. So, in the rear end also this thing will try to crush, okay, or crumple, and it will try to absorb the entire amount of energy, so that least amount of energy is transferred to this zone where our occupants are sitting. Okay. So, this is the philosophy in the design of a car, okay, where the front and the back zones are designed to absorb the maximum amount of energy, thereby protecting the occupants from any injury. Okay. Moving ahead, crash barriers. So, different type of crash barriers we are saying. Okay. So, this is a conventional crash barrier made of steel. Okay. So, these are crash barrier made of concrete, and these are crash barrier made up of steel post and rods. Okay. So, the most commonly employed guardrail system in the world consists of a galvanized steel beam shaped in the front of a W beam supported on steel tubular or channel sections, this one. So, if we cut out this section, okay, this looks like our conventional W beam. Okay. So, this is a W beam as we seen in the last lecture, and this is supported on a tubular channel or wood post. Okay. So, the support can be made up of a wooden post, okay, or a tubular channel type, tubular sections like this. Okay. These are the tubular sections. Okay. So, other protection systems used along highway include concrete parapets. Okay. So, these are the parapets that we were talking about. Okay. So, this form a continuous barrier, okay, along the side of the road, and this is normally employed in the hilly areas, okay, where there is a susceptibility of a vehicle veering off the course and falling into the gorge. Okay. So, there a parapet is constructed so that it forms a continuous system, okay, and this is made up of concrete. Okay. So, what it does is that it has a high inertia. Okay. So, this is very bulky material. It is, since it is made up of concrete, and it can absorb the vehicle impact, okay, using this inertia or the sheer volume of the concrete material. Okay. Sometimes wire rope safety barriers are also used, okay, but their application is limited. Okay. So, in the conventional sense, we will mostly see this type of W guardrails or concrete parapets only. Okay. Moving ahead, rockfall protection. So, rockfall protection we have seen in detail. Okay. So, in the rockfall protection, as we have seen in the previous lecture also, there is a continuous netting. Okay. So, there is a continuous netting applied in the hills also. Okay. Let us say if this is a hills, okay, and if this hills is made up of different fracture types of rocks, okay, and this rocks have a susceptibility of falling down. Okay. So, when they fall down from a significant height, okay, let us say 50 to 100 meters, okay, due to the sheer mass and the velocity, the total impact energy is very high. So, if a vehicle is moving, okay, here, and if any vehicle or any person is hit, okay, there is a high chance of fatality. Okay. So, what is done is a net is applied, along this surface of the hills. Okay. So, there will be an anchor, okay, it will be anchored, okay, and normally it is applied at an angle of 45 degree or more, okay, and the net will be fastened between these anchors. Okay. So, if any rockfall occurs, this rockfall will be going into the net. Okay. And the design of the nets, okay, the material used for the nets are normally wires. Okay. 5 to 6 mm thick wires are being used, okay, and the efficiency of this netting depends upon the thickness of the wires as well as this gaps, okay, the area of this gaps. Okay. So, this is how the rockfall protection measure is being applied. Okay. So, the protective nets made of metal arrest rocking slopes and dissipate its kinetic energy by plastic deformation of the rings. Okay. So, these are the rings you can see, okay, and these are the rings are also made up of metallic material. Okay. So, again they have a high force deformation versus plateau region, and the amount of total energy absorbed depends upon this force deformation region. Okay. So, this is the concept that we learnt in the last lecture that we are using for the design of the any absorption protection system. Okay. Moving ahead. So, the characteristics of energy absorbing materials. Okay. Now, what we are trying to do is that we are trying to quantify, okay, the energy absorption characteristics of the different type of mechanisms used. So, what should be there in an energy absorbing material? So, an energy absorbing material is a device designed to dissipate most of the incoming, okay. Generally kinetic because now we are dealing with the impact event, okay. So, in the impact event the kinetic energy is the one which we need to dissipate, okay, and it does by irreversible conversion to another degraded form of the energy, okay. So, few parameters related to energy absorber, okay. So, let us say a mass and the velocity with the mass and the volume measure of the energy absorbing body respectively, okay. So, this capital M and capital V are the mass and the volume measure of the energy absorbing body, okay. We are defining one quantity as stroke, okay, and the stroke is defined as the displacement of the load application point, okay. So, if the load application point looks, if this is the load application point, then this becomes my x, okay. At the load application point, what is the deformation, okay, or what is the displacement in the energy absorber. The reaction load Rx is the dynamic resisting load developed by the energy absorber as a function of the stroke, okay. So, the reaction load is the dynamic resistance load, okay. So, this is the dynamic resistance capacity of the energy absorber and it is as a function of the stroke, okay, or the displacement that is occurring in the energy absorber. So, the average reaction load over the considered stroke range is given by this expression, okay. So, what it is, okay, here if you can see, okay, the displacement at different points are different, okay. So, here what we are trying to do is that we are trying to put it analyze in an average sense, okay. So, that is why what we are doing is that we are integrating, okay, the reactionary force, okay, over this entire length, okay, and then dividing by the total stroke, okay. So, this gives us an sense of an average reaction load, okay. So, the maximum reaction load is called R max, okay. This value might be either an initial peak or the climax of the load increasing with an x in a monotonic way or some kind of intermediate load oscillations, okay. So, R max or this load oscillations, okay, they are at certain point or at a certain time, okay. R naught gives us a average picture of the efficiency of the energy absorber, okay. So, that is why normally we use EA as the energy absorbing characteristic, okay. So, we will stop here and we will continue our looking into the details of the energy absorbing material in the next class. Thank you.